Welcome to Maths Minders Academy. If this is your first time joining our channel and you are yet to subscribe, we urge you to hit the subscribe button and click on the notification bell icon so that each time we drop a new video, you'll be among the first to be notified. At the end of this video, go to the comment section and share your I want to hear from you. Share your ideas. Let us know how you feel about this video. This is the final part of a two-part video. Here is IGCSE October November 2025 paper 2-1. We have done a video that covers the detailed solution of questions 1 to 13. And today we are looking at the remaining part of the question, that is from question number 4 to the last question. So we urge you to be with us until the end of today's tutorial. Question number 14, we are given a circle here and we are told that what we have, the points A, B, C, D, and E lie on the circle. AC and BD intersect at S, that is line AC and line BD intersect at S. Angle ACD equals 55 degrees and angle CSD equals 88 degrees. So here we are required to find, we are required to complete the statement giving a geometrical reason in each part. So here where the first part is angle CDB equals dash. So let's look at angle CDB. So this is angle CDB. That's C to D to B. So we are looking at this angle. All right. So now that we have a triangle here, and we can see two angles are given here. All right, so this angle D is the third angle. So how do we find that? So we are going to say angle D equals 180 degrees, which is the sum of angles in a triangle, minus 55 degrees plus 88 degrees. Okay, so this gives 180 degrees minus, if we add up these two, remember this is non-calculator, so adding up manually, 50 plus 80 is 130, then 5 plus 8 is 13. Okay, so that's giving us 143. Okay, so here 180 minus 143 will give us 37 degrees. Okay, so this is 37 degrees. So we go back and write this down here. So 37 degrees because sum of angles in a triangle equals 180 degrees. So this is the reason that made us to get 37 degrees. So the next one, angle ABD. Angle ABD. Let's go back to check angle ABD. So this is A to B and to this. So we are referring to this angle here. So if we look at, we can put a line here. We can put a line. So with this, we can see that angle DCA is going to be equal to angle DBA. All right, that's angle in the same segment. Okay, so this angle here is a angle. This angle B is also expected to be 55 degrees. There's a common chord. Okay, both triangle DBA and triangle DCA all lie on this common chord DA. So angle, the two angles, they are equal angle in the same segment. So we go back to complete this. This is 55 degrees. Okay, because angles in the same segment. Angles in the same segment are equal. So that's the reason here. Now let's go back again to look at angle AED. Angle AED. Let's look at this diagram again. Angle AED. A to E to D, we are referring to this angle here. Now look at the shape. Let's look at what kind of shape is this. A C D E. Okay, this is a cyclic quadrilateral. This cyclic quad. Okay, it's cyclic because all the points A touches on the circumference, C touches on the circumference, D touches circumference, and E is also touching the circumference. So that make it a cyclic quad. And so the sum of opposite angles of a cyclic quadrilateral add up to 180, or we can say supplementary. Supplementary means it add up to 180. That is, if I add 55 degrees plus angle E, that's going to give me 180 degrees. So angle E is going to give me 180 degrees minus 55 degrees, and that is going to give me 125 degrees. So we go back now to enter this. So AED equals 125 degrees because sum of opposite angles of a cyclic quad, of a cyclic quadrilateral, sum of opposite angles is 180 degrees. And remember, we can also say is supplementary. Okay, so, and that's what we are required to do here. Now we look at the big question. It said triangle CSD is mathematically similar to triangle BSA, and then we are given the all the details. We are told that DS is 8, BS is 2.7, AS is 4.0, and then we have to work out the length of CS. Now if we go back to the diagram to fix all of this, okay, now this is the diagram here where we are told that triangle CSD, we can see triangle from CS to D, okay, is similar to triangle BSA. Triangle BSA. Okay, so now this angle S in triangle BSA is also 88 vertically opposite angles. Of course, if we now add 88 and 55, That gives us 143. Definitely this is 37. Of course, you also remember that two plane shapes are mathematically similar if they are equiangular. That is, they have the same angles, okay, and then the ratio of their corresponding length will be the same also. So all the angles in the first triangle will also be found in the second triangle. Now we have here that ds is 8, so we have ds, so this is 8 here, that's ds, and then bs is 2.7, and then what else? as is 4, that is a to s is 4 here. Okay, so we are looking for cs. Now look at this. If we look at cs is a length in the bigger triangle, in triangle csd. cs is a movement from where I have 55 degrees to 88 degrees. Go to the smaller triangle, go to triangle bsa, look for a movement from 55 degrees to 88 degrees. 55 to 88 is side bs, so this corresponds. So, and here let's also look at another one given. If we go to the big triangle, let's look at ds. ds is from 37 to 88, so we have ds. Now let's go to the small triangle. 37 to 88 is as. So okay, all right, now let's move back to solve this in the space provided. Okay, so we have said here that cs over bs is equal to ds over as. Okay, these are corresponding side. Okay, and then we are looking for cs. And what is bs? bs is 2.7, and then ds is 4. Okay, ds is 8, as is 4. Okay, and remember that this is also the same as saying cs over 2.7 equals 2 over 1. So if we cross multiply, cs is going to be 2 times 2.7. That's going to give us 5.4 centimeters. So we enter 5.4 here. All right, so let's look at question 5bi, question bii. Say complete the statement. Area of triangle CSD ratio area of triangle BSA equals dash. If you look at the scale factor here, if you look at the scale factor, which is the ratio of the corresponding length, that's 2 over 1. Okay, now area factor here means that we are going to raise scale factor to power 2. That gives us 4 over 1, which is the same as 4 ratio 1 here. Okay, so we are done with question number 14. Number 15, we have to write in standard form 66,000. Okay, if you move 1, 2, 3, 4, so it's going to give us 6.6 times 10 raised to power 4. So we have 6.6 times 10 to power 4. Okay, now look at the big question here. We have to work out this. So let's factor out something here. 10 to power 7. So this is 3.7 times 10, okay, then plus 3.7 here. Okay, now this is 10 to the power 7. 3.7 times 10 is 37, so we have 37 plus 3.7. This is now easy to add because this is non-calculator. We can add this. We know this is 40.7. Okay, this is 40.7. So here we can write 40.7 in standard form also. So this is this, and then times 40.7 is 4.07 times 10 raised to power 1. Okay, so adding up, this 4.07, then using the law of indices, this is 1 plus 7. That gives us 4.07 times 10 raised to power 8. So that will be the final answer, and that's what we are going to enter here. 4.07 times 10 raised to power 8. All right, number 16. For this question, we want to write out, let's see what we want to do here. Say write down all the inequalities that define the region R. All the inequalities that define the region R. Okay, now let's look at it properly. The first, let's look at the line that passes through 2.5. Okay, this is 2.5 here, and this is S equals 2.5, but the inequality, we are picking numbers less than, because it's a thick line. So all the numbers covered here, they are either less than 2.5 or equal to 2.5, but not greater than it. So we have the first one, S less than or equal to 2.5. Now let's take another one. The broken line passing through where y equals 3, okay, which is this line here. Now, because the upper part of that line is shaded, that gives us values of y greater than 3. Of course, we are not picking 3 because it's broken line, so 3 is not, y equals 3 is not taken, and so we are looking at numbers greater, okay, above this line. So we have the second inequality, y is greater than 3. Now let's look at the next one, a line going through where y equals 4. This is the next one, but below that line is shaded and it's thick line, so we have y is less than or equal to 4. All the numbers below 4 or equal to 4. So we have this is another inequality, y less than or equal to 4, and then there's a diagonal line here. There's a diagonal line. Okay, so all we need to do for us to get the equation of this diagonal line, we just need okay, rise over run, can get the gradient. Okay, it passes, if you look at it, if we say y equals ms plus c, here the intercept on the y-axis is 0, so we have y equals ms. So we need m, which is, you know, rise over run. I can pick here. Okay, so it rises by 2. Look at it, look at the rise, 2, and look at the run, 1. So that gives me 2. So the line as an equation is y equals 2x. But as an inequality, we observe that it is below the line that is shaded. Look at that, below the line, and the line is thick, so we have y less than or equal to 2 2x. So enter this. Y is less than or equal to 2x. So we have the 4 inequalities that define the region R. Let's proceed to question number 17. 17a, we are required to find the value of L. Okay, this is capital I, when M is 7, K is 3, and C is 2. So what we do here, we are going to have M is 7, K is 3, so we have 3 to the power 2, and C is also 2, we have 2 to the power 2. So this gives us 7, and this is 9 plus 4. So we have 7 times 13. Of course, you can do this. 13 times 7. We have 21. We have 2 left. 7 times 1, 7 plus 2, 9. So it gives us 91. So this is 91. Now the B part, we are required to arrange this formula to write K in terms of I, M, and C, so that's to make K the subject. So let's get the formula back again. This is what we have. Okay, so we want to make K the subject. First, divide. We are going to divide by M. So if we divide by M, that's going to, so we are left with this. Okay, so again, let's subtract C squared from both sides. So this is what we're going to have. Now, if we take the square root of both sides, so it's going to be plus or minus square root of 1 over M, then minus C squared. Okay. All right. So this is what we'll get if we make K the subject, or we'll write K in terms of I, M, and C. So we have K equals plus or minus square root of 1 all over M minus C squared. Okay. Now let's move on to question number 18. In this question 18, there's issue here. If you look at the right, you can see that this is not quadratic structure. Okay, in a quadratic structure, we are meant to have ax squared plus bx plus c. So here, there was a mistake here. But again, let us express, if we have f of s, so that's going to give us 2s plus 5, 2s plus 5, then minus f of s is this, okay? But again, because the right hand side is not a quadratic, so by the time we evaluate this, okay, let's see what this can give to us. This is going to give us 2x plus 5 into 2s plus 5. That's, of course, this like raising to power 2 here. Then minus, this is going to give us 2 into 2s plus 5, then plus 5 here. Okay, in case we are asked to do this, so if you multiply, if you use 2x to multiply this bracket and use plus 5 to also multiply the second bracket, the minus, this is going to give us 4x, and then this is minus 10 plus 5. So here we get 4x squared plus this is going to give us 10x, and then here is 10x, and then here we have 25 minus 4x minus 10. This is minus 10 plus 5 is minus 5. Okay, and then when we add this, is going to give us okay, we are going to have 4x squared plus this is 20x minus 4s. Okay, then 25 minus 5, so that we have plus 20. So finally we have 4s squared plus 16x, okay, plus 20. So this is how it's meant to be. Okay, and then if you want to suppose we want to bring out the values of a, b, and c. Okay, so here you are meant to have a as 4, you are meant to have b as 16, and you are meant to have c as 20. Okay, I think this is what the exam body wants students to do, but there's an issue here, and so they ask examiners to award bonus of 4 marks to every student. Okay, in the market, so students were awarded this as bonus. All right, so that's it. It's bonus for everybody. And let's move on to number 19. Number 19, what we do here, we can rewrite this as 3 to the power minus x. Okay, and then break this 3 to the power 2, that gives us 9. Then we have x plus 4. Okay, so this is 3 to the power minus s, so this is 3. So we use 2 to multiply this, as 2x, and then 2 times 4 is 8. Okay, so we can equate, since we have the bases to be the same. Okay, we have 3 here and we have 3 here. Okay, so we can equate the powers. So we have minus s equals 2x plus 8, and then if you collect like terms here, you're going to have minus x minus 2x equals 8 here. And so what would this give to us? We are going to get this is minus 3x equals 8. And so if you divide, so we have 8 over minus 3. So here s is going to be, okay, this is going to be 8 over 3, that's 2 whole number, 2 over 3, minus 2 whole number, 2 over 3. That's what this will give to us. So we have minus 2 whole number, 2 over 3. Okay, so let's move on to question number 20. Now, question 20 is probability. Bag A contains 5 white balls and 3 black balls. Bag B contains 3 white balls and 1 black ball. 2 balls are picked at random from bag B without replacement. Find the probability that both balls are black. Okay, so 2 balls picked at random. If the first ball is black, there is only 1 black ball out of the 4 balls, and the second, without replacement, no black is left, but we have 3 balls. So this is going to be 0. Okay, so we have 0 here. The balls The big question, the balls are replaced into the bag. Kel picks a ball at random from each bag. So now we are asked to complete the Venn diagram. Remember, the sum of this value and this value here will give 1. So to get that, I'm going to say 1 minus 5 over 8, which is 8 over 8 minus 5 over 8. And that is going to give me 3 over 8. 3 over 8. Now coming here to pick white ball from bag B. There are 3 white balls. Bag B, there are 3 out of 4. 4 balls are there, 1 black and 3 white. Let's look at it again. If we go to bag B, you can see 4 balls, 3 white and 1 black. Okay, so since this sum will give us 1, so coming down here we do 1 minus 3 over 4. That gives us 1 over 4 here. Of course, picking a white ball is 3. Again, 3 over 4 from bag B, and picking black is 1 over 4. Okay, so that is done. Find the probability that the 2 balls are of the same color. They are the same color, so it's either they are white, or they are black. That's what we mean by the same color, the 2 balls, the white, or black. So coming from this tree diagram, if you look at the first, if you look at white, okay, that's white, look at that. That is going to give us 5 over 8 times 3 over 4. That's white. And so we write that the first is white and the second is white. Or black, look at black here. 3 over 8 times 1 over 4. So we have 15 over 32 plus 3 over 32. And that will give us 18 over 32. That will write that, we can reduce it to 9 over 16. So whichever one is correct. So here we have 9 over 16. Okay, we move on still more on this probability. Here we are told that the balls are replaced into their bags. Joe picks a ball at random from bag A and places it into bag B. She then picks a ball at random from bag B. Find the probability that she picks a black ball from bag B. Okay. Now, she picks a ball. Joe picks a ball at random from bag A. Bag A has altogether 8 balls, 5 white. Remember that for bag A, let's look at it. Bag A, we have 5 white and we have 3 black. Then bag B, we have 4 balls, so we have 3 white and 1 black. Okay, so we are looking for probability that the ball picked from B is black. So, but it picks a ball from bag A. So let's assume that the first ball from bag A is white. So that is going to be 5 over 8. It picks from A. So now if it is white, A is going to have 4 white and still one black. So if it's white from bag A, probability of picking white is 5/8. The probability of picking black is going to be 1/5, because 4 white, 1 black. Okay, if white is picked from bag A and drop into bag B, so B, number of whites in B will increase from 3 to 4, and so the total number of balls in B will increase from 4 to 5. So we have this. Or if he picks a ball from bag A and it's black, 3/8. So if it's black, what's the condition? If it's black, we are going to have 3 white, and then the black will increase from 1 to 2 in bag B. So if it's black that Joe picks from bag A, the probability is 3/8. And then if he's now picking black from bag B, it's going to be 2/5. Okay, so evaluating this, we are going to have 5. The first bracket is 5/40. The second bracket is 6/40. And altogether, the denominator is the same. 5 plus 6 is 11/40. Okay, so this gives us 11/40, and that's what we are entering here. If you find value in this solution and you are yet to subscribe, we urge you to hit that subscribe button now and click on the notification bell icon so that each time a new video drops, you'll be among the first to receive it. We want you to share this video so that others will have access to it, and the YouTube algorithm will be able to move this video to reach other students who are preparing to sit this same examination. Let's move on to question number 21. 21A, we are to write the left and put it in the form of the right. So if we multiply, use 3 to multiply the first bracket, to multiply the second bracket rather, and use minus √5 to multiply the second bracket. This is going to give us 3 times 2 is 6, 3 times 3 is 9, we have √5, minus √5 times 2 is minus 2 √5, minus √5 times 3 √5, this is minus 3, then we have √25. Okay, now this is 6, 9 √5 minus 2 √5 is 7 √5. Okay, then we have 3, √25 is 5. So this is going to give us 6 plus 7 √5 minus 15. Okay, which is going to be 6 minus 15 is minus 9 plus 7 √5. Okay, so compare this with what we have here. You'll see that A is minus 9 and B is 7. Let's move on to next question. Now, the B part, we want to rationalize the denominator. That is going to give us 6/√2 times √2/√2. That's 6√2 all over. This is √4, and √4 is 2. √4 is 2. So if we divide, that's 3√2. So we write 3√2 here. Now proceed to question number 22. We want to solve this. So you cross multiply. If we cross multiply, we have okay, let's use x. We have 2 bracket x plus 2 equals x bracket x minus 1. So we have 2x plus 4 equals x squared minus x. So we can cross everything to this side. We have x squared minus x minus 2x minus 4 equals 0. We have x squared minus 3x minus 4 equals 0. So we look for factors of minus 4 whose sum will give minus 3. So we are using these factors of minus 4. We are using, of course, if we have 4 and 1, we want the addition, the multiplication or the product of these two to give us minus 4 and the sum to give minus 3. So we have minus 4 and 1. Minus 4 times 1 is minus 4. Minus 4 plus 1 is going to give us minus 3. So we write, we have x squared. Instead of minus 3x, we can say x minus 4x minus 4 equals 0. We can now factorize. Okay, then minus 4 is common. Here we have x plus 1 equals 0. Okay, this is x plus 1, x minus 4 equals 0. So either x plus 1 equals 0 or x minus 4 equals 0. Solving here, s equals minus 1 or s equals 4. So we have the solution here. S is minus 1 or 4. All right, let's move on to the next question. Question 23, we have to find the coordinate of the turning point here. Okay, at turning point, there are two methods. Method one, we can say, s is minus b over 2a using the formula method. And what is a here? A is the quotient of s squared, which is minus 1, and b is the quotient of s, which is minus 2 here. Okay, so s is going to be minus times minus 2 all over 2 times minus 1. So this is 2 all over minus 2. So x is going to be minus 1. So here we can get y, substituting the value of x. That's 7 minus 2, s is minus 1. Then minus s squared, s is this. Okay, so we have y to be 7. This is plus 2 minus 1. So 9 minus 1 is 8. So we have the value that we have here is minus 1 and 8. Of course, method 2, at turning point, we can find what the y ds is. Okay, we can use this method. Method 2, we can differentiate. And that will differentiate 7 is a constant, you get 0. Differentiate minus 2s, you get minus 2. And then this is going to be minus 2x. Okay, if you have issue with differentiation, we are going to you can check out our past videos and then get yourself familiar with method of differentiation. So here at turning point, we can say at turning point, okay, the y ds is 0. Okay, because that's the gradient. At turning point, the gradient is 0 because the tangent is parallel to the x-axis, so the slope there is 0. Now, if you set this to 0, minus 2s equals 0, minus 2 equals 2s. So you will see that s is equal to be minus 2 over 2, which is minus 1. Then you substitute minus 1 just like we have it to get the value of y. Alright, so any of these methods can be used. Now let's go to question number 24. This is vector. We're told that in the diagram, OBD and ACD are straight lines. O is the origin, the position vector of A is small a, and the position vector of B is small b. Now BC equals to 1 over 3 OA. We are looking for, we are told that M is the midpoint of CD. So find the position vector of M, which is OM, that is from O to M, that's the position vector. We draw a line from O to M. This is what we are looking for. But bear in mind that if we say BC equals 1 over 3 OA, it tells us that both vectors BC and OA are parallel, because in defining parallel vectors, we say two vectors are parallel if one vector can be written as a scalar multiple of the other. A scalar here is 1 over 3, so we have written BC as a scalar multiple of OA. Vector BC as a scalar multiple of vector OA. So both vectors BC and OA are parallel. So if they are parallel, and then we can also use that to look at the triangles, the triangle DCB and the triangle DAO. They are similar. Okay, if you look at this angle D is common for both triangles, and then this, okay, this is going to be equal to this here, and then let's use a red marker here, and then it means this, okay, is going to be equal to this. All right. Now, so if the two triangles are similar, if we look at BC, okay, over OA, it's going to give us 1 over 3. That's the ratio of their corresponding length. If you look at the length BC in the small triangle and then OA, this corresponds. So we have this. Now we can use that to get a vector OD, because I can get a route for vector OM. I can say OM is going to give me OD plus DM. Okay, so that's the vector route. Okay, so now I need OD, but part of OD is OB, which is known. So if you look at let's look at BD. Okay, it means also that BD, which is this red to this D here, and then BD will go with OD to correspond. OD will also give me 1 over 3. Okay, because it's a corresponding, remember we defined similar shapes, we said the ratio of their corresponding length will be the same. Okay, so now I'm looking for BD. Let's say BD over OD is vector B plus, OD. We can break OD into OB plus BD. Okay, maybe I should take that first, for clarity. So now the denominator OD is OB plus BD. Okay, and this 1 over 3. Then we say BD, OB, as a vector here is B. Okay, then BD. Okay, so let's have our BD, and then this is 1 over 3. So we can multiply. So we have here 3BD is equals B plus BD. So we have 3BD minus BD equals B. So this is 2BD equals B, okay? And then BD is 1 over 2b. Okay, so it's 1 over 2. This is 1. This is now b. Okay. All right. Now I need to get another vector. I need to get CD, and we know that M is the midpoint. Okay. Okay. So now remember, if BC is 1 over 3 OA, that means BC is 1 over 3 A. Okay, so we can get CD, or let's say we want to get DC. Vector DC equals, let's get the route, is DB plus BC. So DC is going to be DB. We are going to take the negative of that, which is minus half. We are going against the direction of the vector, then plus BC, which is 1 over 3A. Okay, so we can now write this as 1 over 3A minus 1 over 2B. Okay, and that is DC. Then DM is half. Okay, because M is the midpoint, so DM is half of 1 over 3A minus 1 over 3B, 1 over 2B. Okay, so that is going to give us 1 over 6A minus 1 over 4B. So DM. So we have DM. So with that, now let us go and get OM. That's the position vector of M. And remember, we say OM is OD plus DM. Okay. And OD is B plus half B plus DM is 1 over 6A minus 1 over 4B. Okay. So let's have, this is 1 over 6A. Okay. B plus half B is 3 over 2B minus 1 over 4B. Okay, so what will this give to us? It will give us, it's going to give us 1 over 6A. Okay, let's have this denominator as 4 multiplied by 2. So this is going to be 6 over 4B minus 1 over 4B. Okay, so this is going to give us 1 over 6A. 6 minus 1 is 5. So we have plus 5 over 4B. 5 over 4B. So that's what this vector OM is. Okay, so we are going to write vector OM equals 1 over 6A plus 5 over 4B. All right, so you can go over this vector and then try to solve it again and check our solution. Now we are coming to question number 25. We want to simplify this algebraic fraction. So looking at the first two, between 10 and 6, 2 is common, and then there is x also. So 2 times 5 is 10, so we have 5a plus 2 times 3 is 6. We have this. Okay, 25 and 15, 5 is common. 5 times 5 is 25, and we have a. And then there's plus 5 times 3 is 15. Okay. And then we can write this as 2x all squared minus 5 squared, so that we have difference of 2 squares here. So going again, we have 5a plus 3b. Factorizing the numerator, we have 2x minus 5. Then all over, applying difference of two squares. This the statement. If we have a squared minus b squared, is going to be a plus b, a plus b, and then another bracket, a minus b. So this is going to give us 2x plus 5, 2x minus 5. Okay, this is what we'll get. Evaluating this more, we see that this and this will cancel out. We have 5a plus 3b all over 2x plus 5. Okay, so we can write that out. 5a plus 3b all over 2x plus 5. 5a plus 3b over 2x plus 5. Okay, so let's move on to question number 26. We have to solve an s, which is minus 1 over root 3 in the range 0 degree to 360 degree. But here tangent is negative. If we look at the quadrant, okay, all of them are positive here. Sine is positive, second quadrant. Tangent is positive, third quadrant, and cosine is positive here. So for tangent to be negative, it means it lies either in the second quadrant or in the fourth quadrant. These are the possible places. Okay, now remember, condition for second quadrant is 180 degrees minus, okay, the acute angle theta here is 360 degrees minus the acute angle theta. Okay, so here we need to get the acute angle, so we can say let theta be the arctan of 1 over root 3. Okay, that's, the acute. And if you look at here, let's get this out. See, this is tan opposite over adjacent. Okay, and then we have this. If you want to get the size of this angle and you are not too certain, remember the hypotenuse, for example, is going to be the square root of opposite and adjacent. So this is going to be 1 plus 3, and then you have root 4, which is 2. So this is 2. And if you do sine, of course, the one that is very common is that if sine theta is 1 over 2 or 0.5, then theta is 30 degrees. So here, theta here is 30 degrees. Okay, theta is 30 degrees. And so second quadrant, to get the value of s in the second quadrant, we are going to do 180 degrees minus 30 degrees. And that will give us 150 degrees. In the fourth quadrant, we are going to have 360 degrees minus 30 degrees, and that's going to give us 330 degrees. So we enter the values of s, 150 degrees and 330 degrees. And so, guys, this is the end of the IGCSE paper 2-1, October, November 2025. If you have found value in our detailed solution and you're not yet part of our community, we urge you to hit that subscribe button now so that you'll become part of us each time we produce a new video. You'll be notified when you click on the notification bell icon, and go on to share this video so that others will also have access to it. Go to the comment section and let us engage with you. What is it that you enjoyed about this video, and which other video do you want us to make? Hold on with us. Next time we are going to discuss another beautiful topic from mathematics. This is Math Minders Academy saying goodbye for now.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams. Caught